Welcome to Code Blocks. Today we will start recursion. From now onwards, mostly I will run my course directly on the coding platform so that you can understand better. I use Visual Studio, that is commonly called as VS Code, for my programming, but you may use any other platform wherever you feel comfortable. Before moving on further, it would be better if you have some basic knowledge about C++ programming, about how to run a loop, the knowledge about pointers, and how to write a function, etc. Just basics will be enough. So let me first explain what is recursion. In layman's term, recursion is solving a complex problem by breaking them into simpler ones. It is a powerful tool in programming. Using recursion, we can call a function from within that function, basically. Now here I have taken a code snippet where I will be calculating the time complexity of recursion. So this is a function of return type void, and the function name is func, and it takes an integer variable n, and within the function there are some statements that if n is greater than 0, then printf uh, the value of n, and then again call this function recursively. So this is an example of a recursive function. Now let us calculate the time complexity of this function. So for that, let us assume that taken for the time taken by the function func is t of n, some uh, expression in terms of n. And since this is an single statement, so I have already explained that any single statement takes 1 unit of time, and this will again take 1 unit of time, and this statement takes 1 unit of time. The answer is no. This statement takes n of n minus 1. See, I have told that the function func that takes an integer value n uh, takes t of n time for execution. Then the function func that takes value n minus 1 will take t of n minus 1. So what is the total time taken by the entire function? The total time taken by the entire function is t of n. Okay, t of n is equals to t of n minus 1 plus 1 plus 1, that is t of n minus 1 plus 2. So since 2 is a constant, then replace any constant the by 1. So 1 basically represents unit time. Constant time means unit time. Okay, so basically the expression comes out to be t of n is equals to t of n minus 1 plus 1. Now if the value is greater than n, then only it will print the value of n, and it will call this function again recursively. So this function takes this much time when the value of n is greater than 0. Okay, so we can define the function t of n as this function is equals to 1 when n is equals to 0 or n less than 0, and this function is equals to t of n minus 1 plus 1 when n is greater than 0. Okay, so we got that t of n is basically t of n minus 1 plus 1. Okay, replacing n by n minus 1, we get t of n minus 1 is equals to t of n minus 2 plus 1. So like this, we will get t of n will be equals to t of n minus k plus k. The recursion will stop only when n is equals to 0 or n is some negative. So assume that n is equals to k, then t of n is equals to t of 0 plus n. Okay, so what is t of 0? Now let's go to the function again. So when n is equals to 0, then these statements will not execute, so the function will take a single unit time. So this means that t of n is equals to 1 plus n. The complexity of this recursive function is order of n. Now next we will see what are the types of recursion. The number 1 is the tail recursion, number 2 is head recursion, number 3 is indirect recursion, number fourth one is nested recursion, and the fifth one is tree recursion. So we will go through each of these type one by one and we will take various examples. Let us run tail recursion. Is when we execute some statements at the calling time, and head recursion is when we execute some statements at the returning time of recursion. So I will now move to the IDE and I will show each of these recursion. So this is the Visual Studio Code platform, and here I have declared a function void fun1 that takes an integer variable n. Inside this function there are some statements, that is, if n is greater than 0, then it will print the value of n and it will call this function again recursively, passing a value 1 less than its previous value. So this statement, this is called as tail recursion, that is, this will execute at the calling time. And if I uncomment this statement, this then this will execute at the returning time of the recursion. So this is head recursion. So here I have declared a main function, and within the main function I have called the function fun1 passing a value 5. Let's run the program and see what the output comes. So the program has run successfully and the output shows that 5, 4, 3, 2, 1. Now let trace this function and see how this output is generated. So here is the program that I have already shown on the IDE. So the output that we got is 5, 4, 3, 2, 1. Now let trace this function and see how the output is generated. So firstly, from the main function, we have called fun1 passing the value 5. Okay, so the first call is fun1 with the value 5. The next, if 5 is greater than 0, if n is greater than 0 and the value of n is 5, if 5 is greater than 0, yes, then so it will print the value 5. So we got the value here 5. 5 is printed. Next, it again calls the function fun1 recursively passing a value n minus 1. So fun1 is again called with 5 minus 1, that is 4. Okay, so next again fun1 is called, yes, 4 is greater than 0, then the value 4 is printed, and then the fun1 is again called with value 3. If 3 greater than 0, yes, the value 3 is printed. Then fun1 is again called with value 2. If 2 is greater than 0, yes, then 2 is printed. Then fun1 is called with value 1. If 1 greater than 0, yes, then the value 1 is printed, and then the value function fun1 is called with the value 0. If 0 greater than 0, obviously not. So recursion stopped here. And then as soon as the recursion is stopped executing, it goes back to the previous value and it will check that if there are some statements which it must execute at the returning time. No, there are no other statements. These are the curly brackets. So this signifies the end of the if statement. So then fun1 is completely executed, then it moves to its previous value fun2, then it again moves to its previous value, and the main function is stopped. This is the tracing of the tail recursion. Now we will see head recursion. Now we will look at head recursion. So I have already written the function here. The head recursion is always executing at the returning time. So let us pass the value, initial value as 5, okay, to fun1. Now let us generate the output first by tracing this function. So I have already shown you how to trace a function. So fun1 is first passed with value 5. Then if 5 is greater than 0, yes, then fun1 is passed with value 1 less than its previous value, that is 4. And there is some other statement, printf, printing the value of n. This statement will execute at the returning time. First fun1 with value 4, this will execute, then at the returning time this value will go on printed. So then fun1 is is 4 greater than 0, yes, then fun1 is called with value 3, and there is some printf statement, so I have keep it blank. Then fun1 is called with value 2 since 3 is greater than 0, and there is again one printf statement. Then fun1 is called with value 1, and we have some printf statement. If 1 is again greater than 0, then fun1 is called with value 0, and there is some printf statement. If 0 greater than 0, obviously not, then this function will stop executing. So since this function stop executing, and it will return to its previous function from where it has been called. So fun1. Next, the printf statement at this position will execute. What is the value of n here? Now what is n? N is equals to 1. So 1 will be printed first. So 1 will be printed first. Next, this has already executed. Next, after printing the value, it will return to its previous call, that is fun1 2, and it will fill up this gap, that it will print the value 2, value of n, that is 2. Then it will return to its value 3, and it will print the value 3. Then it will return to its previous call, and next it will print the value 4, and then it will return to its previous call, and then it will print the value 5, and next it will go to the main function, and the program will stop executing. So the output for this head recursion will be 1 2 3 4 5. Let's go to the IDE and see whether this output that we have traced is correct or not. Now let us check the value output of the head recursion in this program. So let me comment out this line, the tail recursion, and uncomment the head recursion line, and we have passed the value 5 to fun1, and let's see what's the output. Yes, the output is 1 2 3 4 5, and therefore the tracing is correct. Now let me modify this function a little bit. If n is greater than 0, let's say, then delete all this part, and if n is greater than 0, let's say that return fun3 of n minus 1 plus n, else it will return 0. Now when I pass, okay, it has got, okay, so it is showing some error. The error is because this function fun3 is of return type void, and here we are returning some integer values, so it gives some error. So let me change the return type to int, and it should not give me any error. Okay, so let's see what this function is giving the output. So I have added this printf statement so that it will print some value, and let's see what this is printing. This recursive function is printing. Okay, yes, so we got the value 15, and now let's trace this function and see what's the how we are getting this output 15. The output that we got on passing the value fun3, on passing the value 5, output that we got is 15. Now we have first passed the fun3 with value 5. This, since n is greater than 0, this will go on return fun. It will call fun3 with a value less than 1, less than its previous value, that is 4, plus something. So this will execute later on once this function is on the returning time. So this fun3, again 4 is greater than 0, it will call fun3 with value 3 plus blank space. So I will going to fill up this blank space at the returning time. So again 3 is greater than 0, so this will call the value fun3 with value 2, and it will return something. Again 2 is greater than 0, it will call some 1. Again 1 is greater than 0, so it will call fun of 3 plus something, fun of 0 plus this. Now 0 greater than 0, no, so this will return 0. It will not enter the if part, so it will return 0. So this is returning 0. Now it goes back to its previous call, that is here at this statement where fun0 is called. Okay. This is n minus 1. What is the value of n? The value of n is 1 at this point of time, so 1. Now this entire value, that is 0 plus 1, is stored here, and it has gone to the function control has gone to this part, fun3 of 2. So this value is actually 1 plus the value of n, that is 2, so it will give 3. Next again it will go back here, and value of n is 3, that is 3 plus 3, that is 6. This is 3, this is 3 plus 3, that is 6, and 6 is going here. Then the control goes back to its previous call. Then fun of 3 plus 4, that is 6 plus 4 is 10, that is 10 goes back here, and then the control goes back to fun of 3 when 5 with value 5, and this is 10 plus 5, that is 15. So this 15 is stored here, and this value 15 is passed to the main function where it is printed as the output value 15. So this is how the entire tracing process is done. And if you really find this video helpful, then please like, share and comment below. And if you are new to this channel, then please subscribe for the entire playlist on data structures. Thank you.